Hey, good afternoon, guys. So today, I just want to go over certain things for the simple questions for the chapter 3, pre-cal chapter 3 simple questions. So the chapter 3 tests. So in case that, for those who are wondering, things that's going to be on the test. So here's some of the simple questions. So make sure that you know how to do the long division. And synthetic division. Now there's a requirement for doing the synthetic division. So anytime that you deal with the divisor, it's considered a linear binomial. Okay, so the divisor must be a linear binomial. So we can use this synthetic division. Well, if the divisor is something other than the linear binomial, if that's quadratic, cubic, that means you have to use the long division. Okay, so divisor, it's either quadratic or any higher power. Okay, so now here's some of the simple questions. So let's start it off with the first one. So let's say we have 2x squared minus 4x plus 3, and then divided by 2x squared minus 2x. Well, as you can see that here, divisor, it's considered nonlinear, so that's why you want to use the long division process. So dividend, which is the numerator, it's a quadratic trinomial. Divisor, it's linear. Well, that one's a quadratic, not linear. It's quadratic binomial. So in order to get that the exact same 2x squared, so this one is 2x squared already, so we just need to multiply this one by 1. So it's 2x squared minus 2x. So again, in order to find the remainder, you want to subtract, so this one got canceled. But the thing is that, let's start it off with negative 4x minus negative 2x. So negative, negative, which is what, positive, then that turns out to be negative 2x. And then plus 3. Well, this one is not enough to divide it by the divisor, so we just leave it as 1 and negative 2x plus 3 over 2x squared minus 2x. So it's a quotient plus the remainder over the divisor. Now, what about for the synthetic division? So let's say we do have something like x to the power 4 minus 4x to the power 3 and minus 429x plus 18. And then you divide this one by x minus 4. So for the synthetic division, so we just need to list all the coefficients. So starting with 1, negative 4. Now you might be wondering, x squared is missing, so 0x squared, so we need to bring down to 0. And then negative 429, and then 18. Divisor, the way to define the divisor, it's always setting the denominator equal to 0. We'll talk about this one later too, setting the denominator equal to 0 for the VA. So x would be what? 4. So the first number, we don't do anything about it. We bring it down. So 1. 1 times 4, which is 4. Combine them, so then that'll be 0. 0 times 4, 0. 0 plus 0, 0. It's all addition here. And then 0 times 4, nothing. So it's negative 429. And then negative 429 times 4, so it's a big number. So let's just do this. So 9 times 4 is 36, 2 times 4 is 8, plus 3, 11, 4 times 4 is 16, plus 1, 17. So negative 1,716. And then at 18, subtract, so 16 minus 8, 8. And then this one turns out to be 10 minus 1, 9. So 6. So it's negative 1,698 for the remainder. Okay, so the way to rewrite it. So start it off with the quotient. So this one, anytime they divide it with the synthetic division, so the power, it's always 1 degree lower. So it's x to the power of 3, 0x squared, 0x minus 429. And then don't forget the remainder plus negative 1,698 all over the divisor. X minus 4. Again, the structure for this is always the quotient, which is the first 4 terms, plus the remainder over the divisor. Okay. So now let's see what else that we have for the simple test. Another one I would like to talk about here is called the remainder theorem. A lot of people just plug in a number back to the polynomial and try to evaluate it with PEMDAS. I mean, you can do it that way too, but sometimes once you deal with the fractions, it's going to be a little bit difficult. So here's the other way to deal with the p of the number. It's called the remainder theorem. Okay, so you'll see that in a minute. So let's say we have a polynomial. It can be any kind of polynomial. Quadratic, cubic, quartic, any type of polynomial. So let's say that p of x, it's given as x to the power of 3 minus 5x squared plus 6x plus 2. And then you want to find out p of 2/3 or p of any number. So let's say p of 2/5. Now the things that I try to use that plug in a number by using the PEMDAS. So that's going to be a lot of work, because now you have to worry about the numerator, the denominator, and also you need to do the multiplication, addition, subtractions. But that's a lot of work. Okay? So now instead of doing this, we use the synthetic division. So now let's bring down the coefficients. So what we got here is 1, -5, nothing's missing. From the greatest power to the least, everything's given for the coefficient. And then whatever the number that you put in for the x value, it's always consider the divisor. So again, we're using the remainder theorem to find out p of 2/5. Whatever the remainder that you find out here, that's going to be the value of the result. Okay, so the first number, bring it down. So 1 times 2/5, 2/5. So -5 plus 2/5. Not quite sure what that is for those who don't like fractions. Just write it on the side and then find the least common denominator, which is 5. So times 5, top and the bottom. So you got -25 over 5 plus 2/5. So -23 over 5. Okay, so -23 over 5. And then the next one, you want to keep multiplying the fractions. So the next one is going to be -46, because -23 times 2, -46. 5 times 5, 25. So now we got 6 plus -46 over 25. Okay, common denominator, 25. And 25 times 6. Well, 25 times 4, that's 100. So 25 times 6, 150. So minus 46, which is what? 4 over 25. Again, the rest of this is all considered addition here. And then going through the same pattern again. So 4 over 25 times 2/5. So multiplying fractions. So we got 8 over 125. Okay. So 2 over 1 plus 8 over 25. 125. So we got 250 over 125 plus 8 over 125. So eventually we're going to end up with 258 over 125. And guess what? The remainder, and that's the final solution of that p of 2/5. What do you think? Isn't that beautiful? Instead of doing like this, converting that to like a common denominator with all a bunch of fractions. So we just deal with that with the synthetic division. Okay, so now let's see what else that we have for the simple questions for the chapter 3 tests. Oh, another thing, P over Q. So P over Q, there's so many things that you can find out. You can find the possible zeros, and you can use that to find the roots, the zeros, whatever that you prefer to call this, the root, the zeros, or the x-intercept for the polynomial. So now, let me show you one of the simple questions. Okay? Again, we start out with P of x. So we need to find out all the actual zeros, and then we're using the actual zeros to find out the rough graph. Okay, we can do the rough drawing for the graph of the polynomial. Okay, so now let's look at that. So P of x. Well, let's say that we do have something like x to the power of 3, and then plus 4x squared, minus 7x. You know what? Let's just convert that to positive 10. Okay, like that. So now let's use the discard rule to find out how many possible zeros that we can find for the P of x. So there's no sign change here. One sign change, yes. Another sign change. So that means looks like we do have one positive, real, well, two positive real zeros, because that's two yeses, or no solution. Because that, according to the discard rule, it's either the number of sign changes, tells you the number of solution, or it's less than that number by another even number. So 2 minus 2, then that'd be no solution. No positive, 0. And then what about for the negative? Well, for the negative, we need to change the sign first. So negative x power, negative x to the power of 3. And then plus 4 times negative x quantity squared minus 7 times negative x plus 10. So negative x quantity to the power of 3, which is true negative because that's an odd number power. Negative x quantity squared, positive, so plus 4x. Negative times negative, positive, positive 7x, and then plus 10. And it looks like this one, there's only one sign change, and then the rest of those would be no, no. So that means this one is just an indicator. It just shows one negative, real, 0. Okay? So now, how do we find out all the possible zeros for this? So let's go back to that, the rational zero theorem, P over Q. So back to the original equations. So the value P is 10. And then Q, which is 1. So now let's find out all the possible factors of 10 and 1. So we got plus minus 1, plus minus 2, plus minus 5, plus minus 10. All over plus minus 1. So it looks like the polynomial, most likely, is going to be divisible by either one of those selections. Plus minus 1, plus minus 2, plus minus 5, or plus minus 10. So we do have 5 different pairs of the possible zeros. So now let's find out with the synthetic division. So we got 1, 4, negative 7, and 10. And some student might be freaking out, there's so many selection involved. Which one do we choose first? It doesn't matter, you can always choose the small number, or you can choose the median. That's what we talked about that in class. Okay, so the median here, so you probably want to choose either positive 2, positive 5, or negative 2, negative 5. So now let's use negative 5 first for the divisor and see what happens. So the first number, bring it down. So 1 times negative 5, negative 5. 4 plus negative 5, that's negative 1. Negative 1 times negative 5, positive 5. And then negative 7 plus 5, then that'll be negative 2. And then negative 2 times negative 5, positive 10. So that will give you 20. So that doesn't work. What about for positive 5? Would that work? Okay, so let's try positive 5 and see what happens. So first number, bring it down. 1. 1 times 5, 5. 4 plus 5, 9. And then 9 times 5, 45. And then 45 plus negative 7, then that'll be positive 32. Oh, let's see, no. 38, excuse me. So 38 times 5, that would be even worse. It's not going to be remainder, it's not going to be 0. So 5 and negative 5, none of those work. What about, let's try negative 2. 1, bring it down. 1 times negative 2, negative 2. 4 plus negative 2, which is 2. 2 times negative 2, negative 4. Plus negative 7, negative 11 times negative 2. Then it's going to be positive 22. And then, again, the remainder is not going to be 0. So that doesn't work either. And what about for 2? Can we try 2? Okay, so 2. First number, bring it down. So 1 times 2, 2. 4 plus 2, 6. 6 times 2, 12. And then 12 plus negative 7. Then that would be considered 5. And then 5 times 2, which is what? 10. Again, it's going to be 20. So it looks like there's something wrong with the setup here. Okay? Now let's try 1, negative 1, or perhaps 10. Okay? Now let me just change the problem a little bit. So for the positive negative 0, so it's kind of weird because one is even, and the other one is odd number solution. So what happens if I change that 10 to its negative 10? Okay, so 10 to negative 10, and see what happens. So let's try negative 5 once again. Okay, so 1, bring it down. Again, I just make up the problem randomly, but normally the problem that shows on the test is going to work with the synthetic division. So 1 times negative 5, and then 4 plus negative 5, negative 1. Negative 1 times negative 5, 5. And then negative 7 plus 5, negative 2. And then negative 2 times negative 5, 10. Bingo. It works. And now let's just rewrite it. So this one divisor is considered x plus 5. And then the rest of the trinomial is written as x squared minus x, and then minus 2. So if you try to factor the rest of the trinomial, you'll see that it's x plus 5. And then x minus 2, x plus 1. So set equal to 0, we do have negative 5, 2, and negative 1. Okay? So now let's find out. So again, the sign change here. So, well, we need to fix that later. Okay, so don't worry about the sign change for the Descartes rule. We just want to find out all the zeros. Okay, so now let's just plot the points. Okay, so we got negative 5. Okay, so that one's negative 5. So 1, 2, 3, 4, 5, negative 5. And also we do have 2, comma 0. Again, this one's negative 5, comma 0. 2, comma 0. Negative 1, comma 0. So 2, comma 0 is right here. And then negative 1, comma 0. Now the thing is that once we get a point, it's not good enough to sketch the graph. We do know that's a cubic curve, but let's find out the bump of the cubic curve. Okay? So another thing that we can do, after we find the zeros, we can find the Y-intercept as well. The Y-intercept looks like it's going to be negative 10. Oh, there's something wrong with this point here. This one's negative 1, it's over here. So you're trying to find the Y-intercept. So that means you want to put in 0 for x. So we got 0 to the power of 3, 0, 0, 0, minus 10, and that'd be negative 10. So negative 10 is all the way down here. Negative 1, negative 2, negative 3, negative 4, negative 5. All the way down to negative 10. 2, 4, 6, 8, 10. Okay? But the thing is that we still need to find out the bump. How do you find a bump? Now you guys haven't learned about the way to use calculus, the way to find the maximum minimum. So here's the way to find a bump. So you want to do the line test. And the 0 that we have, we got negative 5, negative 1, and then 2. Again, this one is just like a real number line test. Again, the factor that we do have x plus 5, x plus 1, and then x minus 2. Okay, so x plus 5, let's list all the factors here. Again, this one equals p of x. So now we just want to put in the number right between negative infinity and negative 5 right here. So let's say negative 6. So negative 6 plus 5 is going to be negative 1, so it's negative. Negative 6 plus 1 is negative 5, negative. Negative 6 minus 2. Okay, well, let's just write in a number as well. So negative 1, negative 5, and negative 8. Multiply this all together, so the result, which is considered negative 40. It's a very small number down the bottom here. So negative 10, negative 40 might be all the way down to the bottom. Okay, so anything that's negative 6 from this side right here. So it goes down here somewhere. And now, what about a number that ran between negative 5 and negative 1? So you might be wondering, what about negative 4? That works. Negative 4 plus 5, 1. Negative 4 plus 1, then that would be negative 3. Negative 4 minus 2, negative 6. So 1 times negative 3 times negative 6, 18. So we got negative 4 comma 18. Okay, we're going to plot that point later. And now, right between negative 1 and 2, so let's say 0. So we got 5, 1, negative 2. Then the result would be negative 10. So 0, comma, negative 10. And that's what we got already, which is the Y-intercept. And then any number that's greater than 2, so let's say 3. So 3 plus 5, 8. 3 plus 1, which is what, 4. 3 minus 2, 1. So 8 times 4 times 1, 32. Again, it's a big number. So we got 3 comma 32. So 3 comma 32, which is all the way up here. Okay? So now we got a point here. And for 4, x equals, well, negative 4, then we got 18. So negative 4, we got 18. 18 is all the way up here somewhere. Again, this one is the 10 scale. So 18, most likely, is going to be up here. Okay, so now, as you can see, that the graph is going to be like this. Kind of like an N curve. Okay, this one should be a little bit over. So it looks like we find it back somewhere here, and then goes back down, all the way here, and then goes all the way back. So that would be the binomial. As you can see that we do have 3 different portions of the graph right here. So increasing interval, decreasing, and then increasing. So 3 different changes for increasing, decreasing interval. So that's why the highest power is 3. And also it shows that we do have 3 zeros. Well, sometimes they're not considered real. Sometimes one solution may be real, the other 2 they're like imaginary. Okay, so here's what we found. This point is supposed to be connected with the 0. Okay, so the max and the min, don't worry about that. We'll just call this one the bump. Okay, so the first one, the second one for the bump. Okay, so it's N curve. Another thing is that the domain for this one, it's always all real number, and also the range, because this one it goes up and down, there's no any restriction. Also the range, it's considered negative infinity to infinity. Okay. So now let's see what else that we have for the rest of the simple questions. So make sure that you know how to find the rational zeros. Okay, so now let's do the one that without making the p over q, so we can factor it. Okay, so another one. So I'm sure you guys are pretty familiar with the way for factoring. So we can use the double cross method, or we can use the smiley face, or we can use the Puente square, whatever the strategy that you like for factoring. So anytime that you deal with the trinomial, it's better for you to try to factor it first before you do something else. Okay, so especially once you deal with like even power, all the even power, even functions. Okay, so here's one example. So let's say that we get p of x. So that equals 9x to the power 4 plus 25x squared plus 16. Okay, so for those you might be wondering, how do we factor this? Again, it's an even power, so that means this function is considered even. Well, why it's even? Because all the power here, it's all even. It is. 0 is the smallest even number. Okay, so 4, 2, 0. So now let's try to factor it with a smiley face. So 9x to the power of 4, we have 3x squared, and then 16x to the power of 0, well, without the 0, x to the power of 0. So we got 4, 4. So 3 times x squared, 12x squared. 3x squared times 4, 12x squared. Well, but that doesn't work, right? So now let's see, anything that went wrong here. So we try to use this, but it's not factorable. You try to do it that way, so it's going to be non-factorable. So instead of using that 4 and 4, okay, let's try something else. Okay, let's make it this way. So 25. So instead of using 25, okay, so I just want to change the number. So 24. So check it out. So 3x squared, 16, 4 and 4. So we got 12x squared. So we got 24x squared. And that's exactly what we have right out there. Okay, so now let's bring this all together. So we got 3x squared plus 4, and then 3x squared plus 4. So now, for those you might be wondering, it's exact same binomial? It is. So now let's find out the solution for this. So let's say that 3x squared plus 4 equals 0. Just set one of the binomial equal to 0 because that'd be exactly the same thing. So, and then we solve for x. So 3x squared equals negative 4. Subtract 4 both sides, divided by 3. So we got x squared equals negative 4 third. So it looks like the solution is going to be imaginary. Yep, they are. Imaginary solution. So square root, both sides. So we got x equals plus minus 2 over root 3i. And then we need to rationalize it. So it's plus minus 2 root 3 over 3i. And for those who might be wondering, it's the same solutions. So that means we need to put in the multiplicity. Again, what that means is, so multiplicity shows how many times the same solution appear. So it's the same binomial, so that means the same solution that would appear twice. Okay, so multiplicity. Okay, so that's how you find this. Again, there's no need to perform that P over Q. Well, even if you try to do that, it's not going to work. Because none of the solutions, they're considered rational. Again, imaginary, they all consider imaginary number irrational. So they're not part of a rational number. Okay, so now let's see what else that we have for the rest of this. Okay, so let's do one more. And then we'll get into the rational. Okay, so make sure that you know how to FOIL. Combine the imaginary number, not just like finding the zeros. Okay, so here's another one. So let's say that we did give the solution for the zeros, but you need to find out P of x, the original polynomial. So how would you do that? So let's say that we do have the solutions for the, okay, with degree of 4. And then the zeros. And the zeros are given as 1/2, 2, and I. Okay? So now, it's only giving with 3 solutions. So one of those is imaginary. Back to the conjugate theorem. So the conjugate theorem is showing that one of the imaginary solution is the real 0. So that's the first 0. And guess what? It's conjugate. It's also considered the other 0. Then that would be the second 0. So besides I, there's another hidden solution here. It's called negative I, the conjugate. So now let's just set it up. So we got x minus 1/2, x minus 2, x minus I, and then x minus negative I for p of x. And guess what you have to do with the rest of this? All you need to do, just FOIL. Now I'm not going to show how to FOIL that real number, because that's something you learn from Algebra 1. But now for the imaginary, so this one is written as x minus I times x plus I. As you can see that the pattern here is the difference of 2 squared. So it's x squared minus I squared. And this one, just bring it down. And I squared, that's considered 1, negative 1. So negative, negative, so positive 1. And then the rest of this, you want to FOIL first, outside, inside, last. And then you want to figure out what that is. And once you get the trinomial with the binomial,